Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. Okay, the date for today is May 10, 2024, and the time is around 8:43 p.m. Okay, my topic for this evening will be a long video format. It's a continuation of my subject matter analytic geometry, and we are now on lesson number 7. And the title of the topic for this evening will be Slope of Parallel and Perpendicular Lines. This is a very interesting subject matter because under the study of analytic geometry, we've been using the formula on how to compute the slope of parallel and perpendicular lines, but we don't know where it was derived. So for tonight, I will be deriving how come these formulas came out as M1 equal to M2 for parallel lines and the product of M1, M2 equal to -1 for perpendicular lines. Okay, let's proceed. The title of the subject matter for tonight will be Analytic Geometry, lesson number 7, long video format. And the title of the topic will be Slope of Parallel and Perpendicular Lines. Of course, we know what are parallel lines. Parallel lines are something like this. It's just like the rail of a train. And perpendicular lines are actually lines in which the angle between them is 90 degrees. So we will be deriving the formula on how to compute for the slope of parallel lines and the slope of perpendicular lines. Because we've been using the formulas for parallel lines, that is the product, the value M1 is equal to M2. But this was actually derived. It did not just come out like that, it was derived. And for perpendicular lines, we've been using the formula, the product M1, M2 is equal to -1. We've been using this one, but we don't know how it was derived. So for tonight, I will be deriving the derivation of these two formulas. Okay, for parallel lines, I will now be giving the general equation on how to compute for their slopes. If there are two lines, line number 1 and line number 2, of course line number 1 got slope. And line number 2 got also a slope. The problem is, what will be the relation of M1 as a function of M2? What will be the relation? We've been using this one, so let's now try to bring out the derivation of this one. For the figure, this will be the figure, right? We are given the Cartesian coordinate system. This is the y-axis, x-axis. We draw two parallel lines with the slope, positive slope, meaning their slope is from left to right. It should be going up. Okay. So the first line should have a positive slope, and the second line should also have a positive slope. They are both parallel. So if we try to designate the slope of these two parallel lines, for line number 1, I represent the vertical change in y as A, and the horizontal change in x as simply B. This is plus A, and this is plus B. It's in the first quadrant, right? So they are both plus. For line number 2, since they are parallel, of course, the change in ordinate and the change in abscissa will be the same. So for line number 2, if this is A, for line number 1, for line number 2, this should also be A, the change in the ordinate. Okay? And the change in the abscissa, since they are parallel, if this is small letter b, this should also be small letter b. Okay, let's try to bring out the derivation. considering line number 1, if we try to take the slope of line number 1, slope is actually the ratio tangent of this angle here. It will be the ratio A over B. So considering line number 1, its slope, by definition, we pass by this one, right? Sorry for that one. This is A, this is B, this is line number 1, this will be its slope. So if we try to take the slope of line number 1, it will be the ratio A over B. It's a plus over a plus, right? So M1 will be the ratio plus A over plus B. We call this equation number 1. I put the proper sign because the proper sign is actually very important. Consider line number 2. If we try to bring out line number 2, which is parallel to line number 1, this is also A, this is B, this is line number 2, right? So this should be M2, the slope of line number 2. If we try to take the slope of line number 2, it will still be the ratio A over B. I will put the sign plus. This is plus. We call that equation number 2. Okay, so to derive now the relation, we are given two equations. There is a ratio A over B using equation number 1, and there is a ratio over B using equation number 2. So we will equate A over B from 1, and this should be equal to the ratio A over B from equation number 2. So I place it here using equation 1 and 2. So from 1, the ratio A over B is actually M1. And from equation number 2, the ratio A over B, this A and B are the same, right? That's why I didn't place any proper subscript. It will be equal to M2. Okay? So if we now try to equate A over B equal to A over B using equation number 1 and number 2, from equation number 1, the ratio A over B is M1. And from equation number 2, the ratio of A over B is M2. So we could now erase this one. So therefore, I place it here. M1 should be equal to M2. And this should be the relation of the slope of two lines if they are in parallel. Okay? So this is actually slope relation of parallel lines. This one. So the formula we've been using for parallel lines, that is slope number 1 equal to slope number 2, it is this. And actually it was derived coming from this one. Okay, so as long as you know how it was derived, you won't forget the formula and how to take the relation of slope number 1 and number 2 if the two lines are parallel. Okay, next one. The more complicated thing. For perpendicular lines, the relationship of the slope number 1 and number 2 is actually given by the formula m1 times m2 equal to -1, or the more popular one from other books, we just manipulate. We divide both sides by n2, it could be -1 over n2. Okay? But these two here are the same. Or in short, to be more beautifully seen as an equation, the product m1 and m2 equal to -1. How come it was like that for perpendicular lines? Okay, let's try to bring out the derivation. To simplify the figure, we will be drawing two perpendicular lines that passes through the origin, so we could visualize the angles. Okay, so this should be line number 1. Slope upwards to the right. The emanation is from left to right, so if it goes from left to right going up, M1 is actually a positive slope, a plus slope. Okay, and for the next line should be perpendicular to the first line. Okay, so if we try to rotate this line here, we rotate it 90 degrees. Okay, the angle between the new line and the first line will be 90 degrees. This one. That's 90 degrees. So this is now line number 2. Okay, and what's the direction of the slope of line number 2? Uh, the designation is from left to right. So if it is from left to right going up, that's a positive slope. But from left to right, okay, it goes down. So they should be, the slope of this second line will be negative. The designation, proper sign should be negative. Uh, we'll try to bring out how come it was negative. Okay, the increment, the change in y for M1 is actually plus A. This is plus, right? And the change in abscissa is also plus B. They are both positive. That's why I make the figure that the first line should be seen on the first quadrant. And for the rotated line, actually it falls under quadrant number 2 and number 4. So the slope of this should be negative. So if we try to rotate this one, this vertical thing here now, this portion should be a plus B. This is plus B, okay? But this change in ordinate is still a plus. It is above the x line, right? So it is still a plus B. But this portion here, the change in abscissa, a change in abscissa that is to the left, it should be a negative thing. And this is now negative A. It is the opposite of this one. So I place the proper sign here, this is negative A. Okay? So if we try to derive the relationship of the slope of line number 1 and number 2, it will be this. I didn't same as this one. Considering line number 1, M1 will be plus A over plus B. This is a plus, this is a plus. So this is a plus A over B. We remove the plus sign, it is understood to be plus. M1 will be equal to the ratio A over B, equation number 1. Considering line number 2, slope is actually the ratio of this side here over this. Okay? And the angle which line 2 makes with the horizontal is actually its slope. So M2 will be plus B. This is a plus. Over a minus A. Minus A, it is to the left. So this is minus A. So this is now where the negative sign emanates. There is a minus here. Right? So a plus over a minus, the overall sign will now be a minus. Right? So there is a negative sign now. It's not a magic. So considering line number 2, after the simplification, M2 will be negative open quantity, the ratio B over A. I will place the quantity here, meaning to say this negative sign refers to the overall sign of the fraction B over A. We call this equation number 2. Right? From equation number 2, we will solve for B. B will be equal to, this negative here, we could place it under the denominator. So if we try to compute for B, it will be the product M2 times minus A, or it will just be simply negative A times M2. There's a negative sign, right? That's not the magic. 2, equation number 1, meaning this value of small letter b, which is equal to negative A times M2, we put it to equation number 1. So going back to equation number 1, I'm following this. M1, the numerator is positive A. The value of B in terms of A is negative A times M2. Okay? I put a quantity so I can show you the cancellation without any violation. The operation on the denominator is multiplication, so actually we can cancel this A here with this. What remains on the bottom portion will be negative 1. Okay? So m2 times negative 1 is actually m2 times negative 1 is negative m2, right? m2. Negative 1 times m2 is negative m2. We multiply that by m1. m1. And this should be equal to the right hand side will be plus 1. So to make this positive, we will multiply all terms by negative. Negative and negative will not be positive, so I will try to rearrange. The product m2, m1 is actually same as the product m1, m2. And for the right hand side, a positive 1 times negative 1 will be a negative 1. So the relationship of the slope for two lines which are perpendicular, it should be the product m1, m2 equal to negative 1. Or we could change the form, m1 is equal to negative 1 over m2, or it could be m2 equal to negative 1 over m1. This is the so-called the slope of perpendicular lines is the negative reciprocal of the other line. Or just for simplicity, the product m1, m2 is equal to negative 1 for perpendicular lines. Okay, that's it, guys. That's how we derive the relationship of the slope of parallel lines and vertical lines. So from now on, as long as we are studying analytic geometry, for parallel lines, their slope will be the same. And for perpendicular lines, the product m1, m2 equal to negative 1, or the other equivalent, slope number 1 is the negative reciprocal of slope number 2, or the reverse of that one. Slope number 2 is the negative reciprocal of slope number 1. Okay, good evening from Los Angeles, Professor Derivation.